So today we're going to be talking about new discoveries within the origins of the supermassive black hole that is in the center of our very own Milky Way galaxy. In the Sky Report, we're going to be talking about some celestial objects that are going to be in the night sky from Wednesday to Friday. And finally, we're going to be talking about Hubble and Chandra discovering a brand new supermassive black hole out in the cosmos. All that and more will be covered today. This is Interstellar Insights. Alright guys, so to kick it off, we're going to be talking about the origins of the Milky Way's supermassive black hole that is in the center of the galaxy, which is called Sagittarius A. For those of you that aren't familiar, these supermassive black holes do exist in the centers of galaxies, so the Milky Way is not special. There's one in Andromeda, the large magnetic cloud, I believe that's what it's called. They've all got black holes, I believe, supermassive. They're kind of what structure the galaxies due to their immense gravitational forces. But today we're going to be taking a look at the Milky Ways, in this case Sagittarius A. So Sagittarius A, of course, like I said, is located in the center of the Milky Way galaxy, supermassive black hole, and it is located more than 27,000 light years from Earth. And new research is being conducted, mainly from the University of Nevada, Las Vegas, that suggests that Sagittarius A was formed from a black hole merger. So we've seen, if you guys know what binary star systems are, with two stars in a single star system, you can think of it like that, except with black holes. Except in this case, they obviously merged and formed what we call Sagittarius A today. So initially, supermassive black holes such as Sagittarius A, there are two theories to really explain the growth of supermassive black holes. So initially, like I said, they were thought to grow either by accretion of matter over time, that is to say, like absorbing gas and plasma and matter from nearby stars, or that they could only be formed through the merger of two black holes, combining to form a supermassive black hole, which is what the research from UNLV suggests. So researchers from UNLV, once again, University of Nevada, Las Vegas, they analyzed mainly the rapid spin of Sagittarius A, which is very strange. If you put it up against other black holes, it would be kind of like the outlier, if you will. And Sagittarius A also has misalignment. This misalignment of Sagittarius A is relative to the angular momentum of the Milky Way galaxy, which in this sense is basically fancy astrophysics, basically saying that the spin of Sagittarius A is misaligned when you observed from the angular momentum of the Milky Way, essentially. And basically, this evidence is now being used by UNLV researchers to basically claim that supermassive black holes could potentially form from mergers. So, yeah. So from this data, researchers believe that it is from a merger of two black holes, like I said. And the way to really check this, because obviously we can't create black holes here on Earth, nor are we close enough to one, because if we were close enough to one, we'd all probably be dead, and no one would be listening to this podcast. Researchers at UNLV essentially used simulations to see if black hole merger could possibly form Sagittarius A. And from those simulations, researchers at UNLV discovered that a merger could happen in order to create a supermassive black hole. So they discovered that two black holes with a 4-to-1 ratio uh, could be enough to recreate Sagittarius A and all of Sagittarius A's weird spin properties, the misalignment of Sagittarius A based off of the Milky Way's angular momentum. And yeah, and then they predict that this black hole merger likely occurred roughly 1 billion years ago. Now, note that while that may seem like a long time to you, not the Milky Way, the universe has been around for 13.8 billion years. So that's considered not too long ago if we're talking about big time in terms of the cosmos. So, and yeah, that is all that is for this story. Of course, if we get new news, if there are new discoveries, of course that'll be talked about on this show. But Sagittarius A, this discovery is going to contribute further to our understanding of black holes, especially how these giant supermassive black holes form. If all of them are just formed by mergers, or who knows, maybe we'll prove the accretion disk or the accretion of matter theory right, and maybe there's a black hole that we'll observe in the next few years that'll become a supermassive black hole through the accretion of matter. But anyways, that's all I have got for this story. Let's go move on to the Sky Report. Alright guys, so let's go move into this week's Sky Report. So, nothing much happening tonight for Wednesday. The only thing that really happened today happened like in the morning, and that was when the first quarter moon appeared at 2:06 a.m., which was perfect for those that are interested in the moon, looking at the craters and the ancient lava basins, otherwise known as seas. So when you hear people talk about the seas on the moon, that's what they're talking about. Also, I forgot to mention FYI that these times are in, of course, Eastern Daylight Time. So if you do not live on the East Coast, that's a you problem. So you go figure it out. Anyways, that's all for tonight. There really wasn't really anything. But for the 12th, tomorrow, around 1:20 a.m. EDT, Jupiter will be highly visible in the night sky. It'll be spanning 40 arc minutes across the horizon, and it'll be shining at a brightness of negative 2.3 magnitude on the magnitude scale. And if you want to find Jupiter, Jupiter is going to lie between the horns of Taurus the Bull, the constellation, and it'll be in the lower left of Taurus, near the red giant star Aldebaran. Aldebaran. Yeah, that sounds right. Stars are very hard to pronounce. They're the hardest names to pronounce. But anyways, besides Jupiter, Jupiter's moons are also going to be on display. Ganymede is going to be the farthest east of the planet, with rest of the Galilean moons, Callisto, Io, and Europa, are all going to be aligned to the west of Jupiter. So that is tomorrow the 12th. 13th, Friday, the circumpolar constellation Cepheus will be high in the sky after sunset, and the star Delta Cephei will be in the sky in the constellation of Cepheus. It'll be in the lower left-hand corner in the house shape of Cepheus, and that star will be shining at a magnitude of 3.4. So anyways, yeah, nothing much happening this week in terms of the night sky. I will say though, where I live, it's actually kind of weirdly cold. Usually it doesn't get cold around where I live till the end of September, or the latest I've had it is we've still gotten summer heat until October one year. But this year, it got really cold really early on in September. So yeah, anyways, your times are here. So tonight, the sunset's going to be at 7:14 p.m. Moonrise is going to be at 3:08 p.m. And the moonset is going to be at 11:49 p.m. Tomorrow, the 12th, the sunrise will be at 6:38 a.m. Sunset's going to be at 7:13 p.m. Moonrise is going to be at 4:05 p.m. And since it rose up in the horizon so late, the moonset technically doesn't happen till tomorrow. So we'll talk about that later. Yeah, those are your times for tomorrow, the 12th. Now for the 13th, which is this Friday, sunrise is going to be at 6:39 a.m. Sunset's going to be at 7:11 p.m. Moonrise is going to be at 4:53 p.m. and moonset is going to be at 12:51 a.m. I'm assuming that 12:51 a.m. is when the moonset is going to be, because it'll set in a different day, although I don't know like if that's the same-ish time for Friday's moon. But anyways, the phase that these not these moons, we only have one moon. The phase of the moon for this week is going to be waxing gibbous across the board. So I believe there was a no, I'm probably I don't think there is a full moon. Actually, wait, no, was there? Never mind. I think there was. Whatever. That's not the point, because that's not happening within the time frame of the sky report. So that's really none of my business. But I believe the moon is coming off of one that happened last week, or not. Fact check me. Do whatever. Anyways, that is all for this week's sky report. Let's go move on to our second story. All right, guys. Let's go move into our last major segment of today's edition of Interstellar Insights, and we're going to be talking more about black holes, which has been a very common theme. It's been a lot of news going on in the field of black holes in terms of research, and it just so happens that Hubble and Chandra found a black hole kind of binary system, kind of like how Sagittarius A was formed, but before it actually got formed, and it was two black holes. So before we really dive in, we need to I just want to provide some kind of background information. So when we're trying to figure out stuff with black holes, the main tool that we use in the field of astronomy, or where people get data, it's going to be from the National Science Foundation's Laser Interferometer Gravitational Wave Observatory, otherwise known as LIGO. LIGO, I think it's LIGO. Yeah, it's definitely LIGO. Anyways, LIGO is a tool that astronomers use to essentially detect gravitational waves from black holes, mainly black hole mergers, but they're capped at not being able to detect longer wavelengths. So, excuse me, LIGO is a very useful observatory for that purpose, and a lot of astronomers and astrophysicists get their data out of there. So I just figured that was noteworthy, because that is where most of this data is coming from. But like I said, there's a problem with LIGO in that it cannot detect longer wavelengths. Now, in order to fix this problem, NASA and the ESA, or the European Space Agency, if you're not familiar with that, are doing a joint space mission, and that is to build and launch the Laser Interferometer Space Antenna, otherwise called LISA, in the mid-2030s to capture longer wavelength gravitational waves. So think of this LISA kind of like as Chandra or Hubble or one of those satellites, except it's being launched in the 2030s with the sole goal of capturing these longer wavelengths so we can get a better understanding of these black holes. So yeah, that is like the background I want to provide, just so it all fits in context. It's kind of a little bit out of context, but anyways, two actual black holes. These two black holes are approximately 300 million light years apart. So just to recap, 300 years, that's how long it takes for light to go from one black hole to another, although it shouldn't be, because light's obviously getting sucked in. But if you think of that distance, that is pretty small in terms of astronomy and astrophysics. It's actually much longer than you think, but for what we're talking about, it's pretty close. So those black holes are actually relatively close together, just to put it into perspective. The black holes are their location from us is approximately 800 million light years away, and those two galaxies are currently in the state of merging. So scientists believe that the black holes with where they are right now, that we'll see a potential merger in the next 100 million. Yeah, 100 million years. I don't know why I had a weird stutter. 100 million years. But when this merger does happen, this great merger, it's going to send out gravitational waves basically throughout the universe. So if humanity's able to endure another 99.9941 million years, then yeah, we will detect the gravitational waves as they approach us. But anyways, the kind of shocker in all of this is that this discovery was very surprising. Researchers were not expecting this. And to corroborate information with this is that they took archival radio waves from these two black holes, from the Carl G. Jansky Very Large Array satellite array. Think of it like the National Astronomy Isolated Array out in West Virginia, but this time it's in New Mexico. So the Carl G. Jansky Very Large Array out in New Mexico. And the radio waves from there, the archival radio waves from this observatory out in New Mexico, actually supports the existence of there being a merger. And with that being said, they are classified as an active galactic nuclei, which I will admit is a very cool name. But they are classified as an AGN. That's just the abbreviation of active galactic nuclei. I almost said atomic galactic nuclei. But anyways, I'm digressing. Basically, being an AGN means that as black holes, they are getting fueled by gas and dust from the dust. Oh man, English is not my first, or no, it's not my, it is my first language. It's just not my strong suit. Anyways, back to it. Dust from the merger of galaxies. So, something I probably should have mentioned earlier, but is very interesting, is that these two black holes are the centers of two galaxies that are actively merging. So this term, I believe it's official, but the term is galactic cannibalism between two galaxies. So right now, that's going to happen between the Milky Way and Andromeda. Andromeda is going to get the better half because they're slightly bigger than the Milky Way, so we'll merge like in a couple 100 million billion years into one mega galaxy. But that is precisely what's happening here with the two black holes. They're merging together, and they are the very center cores of their galaxies, sort of like how Sagittarius A, we talked about earlier, is the center black hole for our galaxy. But yeah, it seems like galactic cannibalism is happening, and that the cores of these two galaxies are coming together, and they're eventually going to merge into one, at which point the whole galaxy, one of the galaxies should be cannibalized into one giant super galaxy. So yeah, that is what I've got for this new black hole discovery. Who knows, maybe next week I'll just have to keep talking about black holes, because there seems to be a lot of discoveries in that particular field of astronomy and astrophysics that it's very cool, especially in terms of theoretical stuff, theoretical physics. Who knows, maybe someday we'll be able to fully understand them. But of course, these are just some stepping stones for that. So yeah, that is what I've got for this new discovery, this new very surprising and daunting discovery. And hopefully maybe when this podcast is still around in 2035, they launch LISA and we get some new data. So yeah, that is all I've got. Let's go move on to this week's edition of Astronomy Trivia. All right, guys. So welcome to this week's edition of Astronomy Trivia. So before we talk about what this week's question is, we're going to talk over the answer of last week's question. And I believe the question was, what was the purpose of the Dawn mission and where did it go? Or like, where did the Dawn mission go, launched by NASA or something like that? But the correct answer was the asteroid belt. since I use YouTube polling and Spotify, all the nerds out there are going to be pointing, actually, they went to Sirius and Vesta. And that is correct. It's just that you can't really multi-select. I mean, you probably could for Spotify, but not YouTube, so I just kept it general. But yeah, the Dawn mission, launched in September 2007, was to go to Sirius and Vesta in the asteroid belt. They're both, Sirius is a dwarf planet. Vesta is not quite a dwarf planet. It's like a protoplanet. I believe that's the official classification. But anyways, like I said, Dawn was launched in September 2007, and it first flew into orbit of Vesta in July 2011, and then it later entered the orbit of Ceres in late 2012. And then, of course, NASA did some observations, things of that nature. But anyways, let's move on to what the question for this week is. And the question is, who is known for their work on Saturn's rings? I'm going to say that again. Who is known for their work on Saturn's rings? I'm going to put a poll out there, YouTube and Spotify, for wherever you're listening from. And of course, the question will be revealed in next week's podcast episode. And of course, where there will be a new question waiting for you. So yeah, that is this week's edition of Astronomy Trivia. Let's go close out this week's episode of Interstellar Insights. Alright guys, so that is all I've got for this week's edition of Interstellar Insights. Next week should be regular song and dance. I'm still getting into the swing of things with school, so bear with me for that. And yeah, that's all I've really got to say. So if you like this episode, feel free to like and subscribe. It really does mean everything to me to get all this support. And if we grow, that allows this podcast to be better. We can see some better content, through funding and stuff. Who knows? Maybe more interviews, stuff like that. But yeah, that is all I've got to say. This is Michael signing off.